Previously, we've counted functions. So let me start by asking you as a review, x and y are finite sets. How many different functions are there from x to y? And this will be expressed in some expression that is related to the cardinality of x, cardinality of y, and algebraic or arithmetic operations. So if x and y are finite sets, how many different functions are there from x to y? Cardinality of y raised to the cardinality of x power. Y'all agree? All right, so you're going to have x different slots, or cardinality of x different slots. And in each of these slots, you have cardinality of y choice. So you're multiplying cardinality of y times cardinality of y times cardinality of y, cardinality of x times. So you get the cardinality of y raised to the cardinality of x. And if you work with specific numbers, sometimes it helps jog your memory or make these abstract symbols more concrete. And you can use this in lots of different situations. Like, how many subsets are there? In general, we can do subsets in this way. I'm really glad you asked that question. So in general, you can think of a subset. Okay, so the question is, how many subsets does X have if X is a finite set? So for the one that you gave, one that you had, it was a 3-element subset, and that was just going to be brute force of like listing them all out. But in general, we can be a little bit more sophisticated than that. You can think of a subset as a series of yes/no questions. So if I have 1, 2, 3, 4, and I look at the subset 1, 4, I can think of that as corresponding to 1, 2, 3, 4 with 4 slots, and I'm saying yes, 1 is included in the subset. No, 2 is not included. No, 3 is not included. Yes, 4 is included. So you can think of any subset that you look at as going through all the elements in the subset and looking at yes or no for each one. Each subset you see corresponds to, is there a sequence, yes, no decision, one after the other. If you decide to include it, you said yes. If you don't, you said. So how many subsets would there be for 1, 2, 3, 4? 2 to the 4th, why? Because this is a sequence of decisions or sequence of tasks or slots, however you say it. In this subset, we had 2 elements. 4 choose 2 would be if I were only taking 2 elements. So if the question was about 2-element subsets, 4 choose 2 would be right. Yeah, 4 choose 2 would give me the number of 2 elements of 1, 2, 3, 4. Because there, my goal is to say yes exactly twice. 4 choose 2 is taking 2 things out of a set. I have 2 choices for each possibility. So I have 2 times 2 times 2.